Let us convert D flip-flop into T flip-flop. To convert D flip-flop into T flip-flop, we have D flip-flop, so this will be D flip-flop. So only one input will be present, that is D, and this another input we need to cancel it out. So we have only one input D, and we need to convert this D flip-flop into T flip-flop, so your final input will be T. Okay, so depending upon this T and this present state, we'll find out the combinational logic to convert D flip-flop into T flip-flop. So final input we have as T, and present state we have Qn, next state we have Qn plus 1. So again 4 combinations between input T and the present state. They are as follows. As far as characteristic equation for T flip-flop is concerned, it is T XOR with Qn. So with the help of characteristic equation, we'll find out the next state, that is nothing but XOR logic between input T and Qn, that is nothing but 0 1 1 0. This is the XOR logic between the inputs, and we need to excite D flip-flop. So from the excitation table we need to find out D, but we all know that D is the delay flip-flop, and from excitation table whatever the input present, that will be directly shown as it is to the output. So it will be 0 1 1 0 as it is. The next state will be shown as it is in the D flip-flop. So let us solve the K-map for D. So here D will be equal to T Qn bar for this section plus T bar Qn. So this is nothing but D is equal to XOR logic between T and Qn once again. So you can easily modify this combinational logic and find out the conversion of D to T flip-flop. So here is the final diagram for conversion of D flip-flop to T flip-flop, and the combinational logic is replaced by one XOR gate here. In this presentation we will see the conversion of flip-flops. We will convert T type of flip-flop into D type of flip-flop. So what we have is T flip-flop, we have there is having an input T, and we'll convert this T flip-flop into D flip-flop. So final input will be D. So I'll find out the combination between D and the present state to convert it into D flip-flop with the help of T flip-flop excitation. So we have input D, present state Qn, next state Qn plus 1, and I have to excite T flip-flop, okay, from the excitation table. So let us find out the input combination for D and the present state Qn. First of all, we'll keep constant D bit. So D bit is 0. The Qn can take two values, 0 or 1, and if D bit is 1, Qn take again two values, 0 and 1. So next state can be given as characteristic equation of D flip-flop, that is nothing but Qn plus 1 is equal to D. So directly we have characteristic equation as, what are the column D is there, copy it as it is to the next state. So we'll get 0 0 1 1, and with the combination of present state and next state and the help of excitation table, we will get the excitation table for T flip-flop. So first input is 0 0. So for 0 0 I have T is equal to 0 in the excitation table. For 1 0 I have 1. For 0 1 I have 1, and for the last input combination, that is present state 1, next state 1, I have 0. So it is clear that if you observe these two entries, T is equal to D XOR with Qn, you will get, because for this section it is D bar Qn, and for this one it is D Qn bar, that is nothing but D XOR with Qn. So here is the final diagram for conversion of T flip-flop into D flip-flop with this combination logic replaced by XOR gate, through which D XOR with Qn, it's a combination between input and present state to excite the T flip-flop such a way that it will behave as a D flip-flop. That's all about the conversion of flip-flops. Thank you.